Okay, we're going to start talking about the even and odd properties. So I have this drawing here, and what it is, it's a drawing that shows a positive angle going up. That angle is called t, and then a negative angle going down, that's called negative t. So at each of these places, the x value is going to be exactly the same because we're going to go the same distance up and the same distance down. So we can see here that the x value would be exactly the same on the unit circle. Now the y value differs by a minus sign, so one's positive and one's negative. Based on this, we can come up with a couple definitions, and these are going to be called the even-odd properties, and it's going to come off of the circle that we have here. So what we can see here is that if I go down with a negative angle, the x value refers to a cosine and the y value refers to a sine. So if I do cosine of negative t, so the x value, this means the x value when I'm at negative t, that x value is exactly the same as the x value if I had a positive angle. So that would be cosine t. So cosine negative t is the same thing as cosine of t. These x values are exactly the same. So therefore, now I have a way to get rid of a negative angle. If I have a negative angle, I can rewrite it as a positive angle, and that's the relationship here on that. Now let's take a look at sine. Sine would be the y value. And I notice that the y values differ by a minus sign. So if I write sine of negative t, that's the same thing as negative sine t. So again, the y value that's down here would be the same as the y value here, except I'm adding a negative sign to it. So that's another property that we have. If I look at the tangent, tangent involves the y value over the x value, or also I can consider that as a sine over a cosine. So if I take these two and I divide them, I would also get a negative in there as well. So tangent negative t would be equal to negative tan t. So this would be the next formula that we would have with that one. We're going to continue on. Let's take a look at our reciprocal functions. I have secant of negative t. Now secant is the reciprocal of cosine. So because this one doesn't have a negative sign in it, that means that the secant will not have a negative sign either, because again, secant and cosine, those are both reciprocals of each other. So this would be equal to secant t. Okay, so again, these right here, secant is positive because cosine is positive. So if I do the same thing for cosecant negative t, okay, now that's going to be reciprocal of this one. So if I take reciprocal of that, that's going to be negative cosecant t. And then if I do the cotangent, cotangent is the reciprocal of this one, the tangent one, so that would be negative tan t. So here they all are. These are called the even-odd properties, and we see that the only ones that end up being positive would be cosine and secant. These are the only ones that are positive. Everything else is going to be negative. So that's the way that you can remember that. If I have a negative angle inside, if it's cosine or secant, I can just get rid of that negative completely and it's positive. For all the other ones, the negative inside in a way kind of comes on the outside there, and then I have all positive angles that are here. That's really how it works. So it's a way to take a negative angle and rewrite it as a positive angle. Next, we're going to take a look at the periodic properties. Okay, so here's the periodic properties. Let me explain how we got these. Let's suppose here's the drawing I had earlier. If I start at this angle right here at t, and this part right here, 2 pi k, that's talking about how many revolutions we're going around the circle. So the 2 pi represents 1 revolution. If I have this in degrees, I would have a 360 pi, so it can be displayed either way. This is the radian version, but I could also have degrees. If I add 360k, that means I'm going around 1 revolution. If I go around once, it's going to take me back to the same place that I started from. I'm still going to have the same x and y value I had before. That's not going to change because all I did was I just went around the circle once. Well, what if I go around 2 times or 5 times or 20 times? It doesn't matter. I'm still going to end up getting back to the same place that I started from. that's exactly what this property says. If I start with my angle and I add a whole revolution to it, that's going to take me back to the same place I started from. It'll be just as if I just went up this way to T only. Even though I have a whole revolution around it, doesn't matter. That still means I'm going around to T. So for all these, every single one of these, it all works the same way. I can ignore the extra revolution I'm going around. Again, the K value, your K would be integer values. So I could have -2, -1, 0, 1, 2, keeps on going that way. These are all going to be integers. I can go -2, instead of going around counterclockwise, I could go around this way, but it doesn't matter if I go counterclockwise or clockwise, it's still going to take me back to the same place that I started from. So that's why your K value can actually be any kind of integer here in this case. So in this case, all these, you can actually just ignore those, and it'll take it back down into just whatever the regular T value is. So going around once is just as if I just went up to T only, and that's basically what all these properties says. So now that I've looked at, we've taken a look at now the even and odd properties, and we've looked at the periodic properties. Now the next videos will be examples utilizing these properties and also reference angles that we talked about in the previous section.